Hi, I'm JD, and what we're going to be doing today is testing independence. So let me read the problem. Are movie emissions related to ethnicity? A study was conducted in hundreds over 2 years. At alpha equaling 0.05, tests a claim that movie attendance by year was independent of ethnicity. So step one is always to state your hypothesis. So step one. Now for your null hypothesis, your alternative hypothesis, your null hypothesis is that they're going to be independent of each other. So movie attendance by year is independent of ethnicity. And your alternative hypothesis is when they are dependent. So movie attendance by year is dependent of ethnicity. Now, this always includes equals, and this always includes not equals. On top of that, independence, what that means is that one does not affect the other. Dependent means that they do affect one another. So, and always label where the claim is at. Step two, you're going to have to find the critical value. Now, when you're testing independence, it's always going to be right-tailed, always. And you're going to use the chi-squared test, so that means for your critical values, you're going to use chi-squared. So this area right here is 0.05. Your degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So the number of rows is 2. 2 minus 1 is 1. And then columns, 4 times 4 minus 1 is 3, and then 1 times 3 is 3. So break out your table. Now, degrees of freedom, when it's 3, your alpha reads, and on here, again, whenever you're looking at these tables, look at the picture at the bottom. I need to find this area right here, which is 0.05, which are my columns. So 0.05 for alpha with degrees of freedom of 3 is 7.815. Now there's that. Now the next step is kind of tricky because you have to find step 3 is you have to find the chi-squared, which equals the summation of the observed minus the expected squared over the expected. Now, how do you find the expected? Well, the expected is found by the row total times column total over grand total. So you have to calculate the column total, column total, column total, column total, and then the row totals. So let's do that together. And I'm going to do this one at a time. Now, this is a long process, so if you just want to skip through the video, that would be fine. So 1003 plus 987 equals 1990. Clear. 253 plus 298 equals 551. Clear. 173 plus 151 equals 324. And then for other, it's going to be 100 plus 113, which equals 213. And now my rows, 1003 plus 253 plus 173 plus 100 equals 1529. And then I have to add those for 2019, which would be 987 plus 298 plus 151 plus 113 equals 1549. Now let me calculate this. They should be both the same. That's a way to check yourself. So 1529 plus 1549 is 3078. So 1990 plus 551 plus 324 plus 213 equals 3078. So right track. So that's good. But now you have to calculate this. Now I'm going to put the expecteds right next to it. So 1003 right here, and then the expected right here. Now with the expected, it's going to be a decimal, and so I would round to 2 decimal places suggestively. So and then multiply the column total times the row total, and then divide it by 3078. So that'd be 1990 times 1529 divided by 3078 gives me 9888.53. Do the same thing with this one. That value. Clear. 990 times 1549 divided by 3078 gives me 1001.47. This is 253 and the expected value is 1,529 times 551 divided by 3,078, which gives me 273.71. 298, I'm going to budge that a little bit. So clear 551 times 1,549 divided by the grand total, 3,078, gives me 277.29. And then this one, I have 324 times 1,529 divided by the grand total, which gives me the expected value of 160.95. Do the same thing with this one. Clear. 324 times 1,549 divided by 3,078 gives me the expected value of 163.05. Last column. So this was 100, and then I'm smearing it. It's 100. That was 113. So 213 times 1,529 divided by 3,078 gives me 105.81. And I'm rounding, of course. On the calculator, I'm getting 105.80799, whatever. 213 times 1,549 divided by 3,078 gives me 107.19. Alright, so I'm just going to calculate these values, and I have approximately 8 values. And let me show you the first one. And so record all this information. You have the observed and then the expected. So we're still on step 3. So you have the summation of the observed minus the expected squared over the expected. I'm just going to write all these out. And so you have 1,003 minus the expected 988.53 squared over 988.53 plus. And you want to do it in a systematic way. So I would either go across like this or do it by column, because you want to make sure that you have all of them. And then you can count the squares, and there's 8 of them. So I'm just going to go across 253 minus 273 .0 1.71 squared over 273.71 plus it's getting hard to see, plus, right, I have now African Americans in 2008 expect the observed is 173 minus the expected, which is 160.95 squared over 160.95 plus 100 minus 105.81 squared over 105.81 plus, now I'm in the second row, so 987 minus 1001.47 squared over 1001.47 plus 298 minus 277.29 squared over 277.29 plus 151 minus the expected for, and this is African Americans in 2009, which was 163 for the expected, 0.5 squared over 163.05 plus 113 minus the expected, which is 107.19 squared over 107.19. That's a large calculation. And I would split it in half, because with some scientific calculators you're kind of limited on space. So let me count to see if I have all of them, and I should have 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I do have all of them. And again, I'm going to split this up, and I'm going to split it up into the first half and then the second half. And I'm going to round to 3 decimal places for each of those. So I'm just going to type in the first one, first 4, 1003 minus 988.53 squared, parentheses, squared, divided by 988.53 plus parentheses 253 minus 273.71 parentheses squared divided by 273.71 plus, now I'm right here, parentheses 173 minus 160.95 parentheses squared divided by 160.95 plus 100 minus 105.81 parentheses squared divided by 105.81. And I get approximately 2.9999999. So it's approximately 3.000. And again, I'm rounding 3 decimal places because my critical value is at 3 decimal places. Now let me do the last 4. 987 minus 1001.47 parentheses squared divided by 1001.47 plus, and now I'm right here, almost done, 298 minus 277.29 parentheses squared divided by 277.29 plus 151 minus 163.05 parentheses squared divided by 163.05 plus parentheses 113 minus 107.19 close parentheses squared divided by 107.19, and I get approximately 2.961. And when I add those together, I get approximately 5.961. Now I have to make a decision. So, where am I going to put that? Alright, copy this down if you don't already have this written, because I need space to put step 4 and step 5. So if you didn't get those, just go back and copy them. Alright, step 4. I have to make a decision. Now, look at my critical region or rejection region. Does 5.961, does that fall in the rejection region? No, it doesn't. So you not reject HO. And notice where your claim is at. Your claim is in null hypothesis, and you can only reject the null hypothesis. So your conclusion is going to be in reference to rejecting it. So is there enough evidence to reject it? No, there is not enough evidence to reject the claim. So step 5, there is not enough evidence, to reject the claim that movie attendance by year was independence of ethnicity. And that's it.